Though our understanding of how to build For almost as long as there have been roads, there have been professionals responsible for maintaining those roads. Road agent, road supervisor, pavement manager, whatever the title, it never has been an easy job. Though our understanding of how to build better roads has increased and technology has advanced, today's road superintendent faces all of the maintenance problems of his predecessors, plus the pressures of ever-tightening municipal budgets. To his advantage, he can call upon powerful, sophisticated time and labor-saving tools such as the road reclaimer, high production profilers, the automated paver, and the tape measure. That's right. The humble tape measure is one of the simple instruments vital to the latest road management systems. And these road rating programs are really powerful tools. They provide many benefits to the town while helping the road supervisor perform his job more efficiently.
Check. I think we have to measure the depth of it so we can get the severity.
An inventory of your road system eliminates guesswork. You have a record of every mile of road, and you know what its condition is. You get the information you need to anticipate needed repairs and improvements in your road system. That enables you to make repairs in a planned, cost-efficient manner. Maintenance needs are documented in specific numbers. You can demonstrate to town officials where road problems exist and project what they will cost to repair. That allows you to determine a total budget to repair all problems or to show which repairs will be deferred if the budget is cut. Established logical maintenance plans for the whole road network will allow you to resist pressure from individuals who want their road fixed first. Should town officials be sued due to an accident caused by a road maintenance problem, the courts are less likely to award damages when the town is following a documented road maintenance plan. So road management systems make sense for many reasons. But what's involved in putting such a plan together? There are several steps to be followed carefully, and a nominal software charge, but nothing terribly difficult. The rest of this tape will show you how to use a management system for unsurfaced roads that has been developed by the U.S. Army Cold Regions Research and Engineering Laboratory. It's called the Unsurfaced Roads Management System. The field manual, Rating Unsurfaced Roads, will give you even more detail if you decide to use the program. At the end of this video, we'll tell you how to get more information. In a nutshell, here's how the program works. First, roads are divided into representative sections called sample units. Next, all the problems within these sample units are measured and noted. Then, with these measurements as a basis, a few simple calculations yield a number for each sample unit called the Unsurfaced Roads Condition Index, or URCI. Usually, the superintendent's role is to choose the sample units and do the calculations. The road crew does the actual measurements. Now, let's take a closer look at the process. First, we need to choose our sample units. This step takes some patience. It must be done carefully, but it's only done once since these same sample units will be studied yearly. Start with a map of all of your roads. To make sure that the sample units are truly representative of all of your roads, we will go through a three-step process. First, branches. Divide your roads into major recognizable units. In many cases, these will be entire roads. Identify branches with existing names whenever possible. Here we call Boot Hill Road BHR. Next, sections. Sections are parts of branches where road conditions are uniform. For example, Boot Hill Road shows 4 sections. BHR 1 is a mile-long gradual hill, pretty much the same throughout. After the intersection with Dodge Road, there is less traffic, so we call it BHR 2. BHR 3 has still different characteristics because it runs through a poorly drained area, and BHR 4 is a parking area for the town pond. Once you've chosen the sections, label them clearly on a map. Finally, we divide the sections into sample units, where conditions will be studied. In general, sample units are about 100 feet long, and you will want to take detailed distress measurements on about 2 of these per mile. Mark your sample units well. both on maps and with permanent stakes at the site. This stretch of BHR 3 has a problem with potholes, so we chose a sample unit that includes some of the potholes and some of the good road. The field manual will give you more details about making these divisions. With all sample units selected, mapped, and marked, measurement may begin. As with any scientific procedure, consistency is vital. Be sure that your crew understands the importance of their surveys. Observations should be made at the same time each year, when the roads are in their best condition, and data must be gathered in a consistent fashion from year to year and from crew to crew. As the crew makes measurements, they fill out an unsurfaced road inspection sheet. They will measure 7 distress types for quantity and severity. With this information, you will be able to calculate a rating called the Unsurfaced Road Condition Index for each sample unit. This index, based on careful measurement, gives you an easily understood profile of the condition of each road. The calculation may be done manually or with a computer program called PAVER. To perform the calculation manually, refer to the unsurfaced road inspection sheets turned in by your crews. Start by determining density of each distress type. Divide the amount of the distress by the area of the sample, then multiply by 100. Here you have 100 linear feet of improper cross-section, and the total area of the sample unit is 1,800 square feet, so the density is 5.6. Next, refer to the curves in the field manual for each distress type. An improper cross-section of low severity with a density of 5.6 yields a deduct value of 13. When you've determined all of the deduct values for the sample unit, add them to get the total deduct value. Here it's 64. The number of individual deduct values greater than 5 determines the Q value. Here we compute a Q of 3. Relating these two figures to the URCI curve, we find an unsurfaced road condition index of 59 for this sample unit. A section total is the average of all the sample units in the section, and the rating for the whole system is the average of all sections. See the manual for more detail. Now, how do we utilize this figure? Well, you may use the URCI to develop priorities for maintenance. If you set an overall target index of 65 and your current rating is 50, you can use the index to determine which roads you should improve with available funds. Since all improvements will probably not be completed this year, the data is useful in justifying next year's budget. The index also gives you a basis for projecting future requirements and tracking road deterioration with time. When the program has been in place for 2 or 3 years, you will know what maintenance practices work best on your roads and what they cost. This data will make budget forecasting easier and more accurate. These are just a few of the ways that this management tool will help you to do your job better. As you become accustomed to using the system, other benefits will become apparent. Contact Krell for the latest information on how to get started with road management. We'll send you a copy of the Unsurfaced Roads Field Manual. Also available is a videotape on proper road inspection techniques for the Unsurfaced Roads Condition Index.
Unpaved roads can be a real challenge, not only to drive on, but also to maintain. Fortunately for the road maintenance professional, years of steady advancement in product design have resulted in today's efficient tools. So, responding to the problems that occur on the unsurfaced road is a lot easier and faster than it used to be. But if you've ever replaced a washed-out culvert in the middle of the night, you know that even with modern tools, it's far better to anticipate problems than to react to them. The best way to keep ahead of road problems is to use a pavement management system. This videotape will show you how to take measurements for the Unsurfaced Roads Management System. It's a tool that will help your road department actually see into the future. Road maintenance will be planned more precisely. It also helps you to be more efficient on a daily basis and tracks the information needed to show townspeople that you're doing the best job possible. The system is the product of several years of research and development by the U.S. Army Cold Regions Research and Engineering Laboratory. Your accurate measurements are the most important part of the system. In this tape, we will show you how to measure and record 7 road problems called distresses. This field manual will be an important guide for you. In the back of the manual is an inspection sheet. This is the form you'll use when you measure the distresses. The areas where you will make measurements, called sample units, have been marked for you. Your inspection involves measuring all of the distresses in the sample unit. They are improper cross-section, inadequate roadside drainage, corrugations, dust, potholes, ruts, and loose aggregate. Let's look at the proper measurement procedure for each of these. Start by filling out the information at the top of the inspection sheet. You'll find the branch, section, and sample unit information on a map that's already been prepared. Be sure to fill in your name and the date. Then start by measuring the area of the sample unit. That's the length times the width from one shoulder break to the other. Make an overhead sketch of the unit showing areas of problems and road features such as culverts. First, let's look at improper cross-section. As you know, a proper cross-section looks like this. It has sufficient crown, or bank on curves, to carry water to the ditches. Even a slight ponding of water indicates improper cross-section. Here, the road surface is level, and there's evidence of a small amount of standing water on the surface. This is called low severity. When there's a slight bowl shape or evidence of a moderate amount of standing water, we call it medium severity. Evidence of a lot of standing water or the presence of severe depressions puts it into the high severity classification. To measure improper cross-section, use a straight board. This is medium severity. The critical measurement is the number of feet of each level of severity. Here, the sample unit has 40 feet of medium severity and 20 feet of low severity. Next, we look at inadequate roadside drainage. When ditches and culverts fail to carry runoff, pools form alongside the road. The presence of these pools can weaken the road, or they may drain across the road carrying surface material away. Look for ponding of water or evidence of ponding water, and also for overgrowth or debris in the ditches. Again, you need to record the length of the problem in feet. This sample unit has 15 feet of medium severity, and beyond that 30 feet of low severity. Refer to the field manual for help in judging severity level. Number 3 on the inspection sheet is corrugations, or washboarding. We measure these by putting a straight board across the top and measuring depth. Severity is indicated by the distance between the high and low points of the corrugations. Record the area in square feet at each level of severity. This sample has 126 square feet at the medium severity level. To measure dust, just have someone drive through the sample unit at about 25 miles per hour and observe the dust cloud. This sample has a medium severity. This is a single rating for the whole sample. Check the appropriate box. Potholes are a familiar sight. First, measure their diameter and depth. This one is 3 feet in diameter by 3 inches deep. Next, refer to the table in the field manual to determine severity. So, here we get 1 at high severity. Record the total number of potholes for each severity. Again, using our straight board and tape measure, we classify ruts. These ruts are about 3 inches deep, so they're of the medium severity. And with a dimension of 4 feet by 10 feet, we record a total area of 40 square feet in the medium column. If there are ruts of any other severity, we record the total area of those as well. Finally, loose aggregate is the rock, sand, or soil that builds up into ridges along the center or sides of an unsurfaced road. The height of the berm is the key to its severity. Measure this, check the table in the manual, and then measure its length. In this case, the sample has one berm at medium severity, 20 feet in length. You'll no doubt run into situations where it'll be difficult to tell which distress is which, or several may occur together. A sample with improper cross-section may also have potholes and ruts. In this situation, use your best judgment. Decide which is which, and then measure each distress separately. The system is flexible enough to give an accurate rating under most circumstances. With experience, spotting the different problems will become much easier. That's it for measurements. Your numbers will now become the basis for calculations to be performed back at the office. The final result of this process is a solidly based maintenance program. The importance of your careful measurements can't be overstressed. With your help, the Unsurfaced Roads Management System will provide the information needed to maintain and improve your roads at the lowest cost. Instead of reacting to the disasters that Mother Nature, Father Time, and your unpaved roads cook up for you, you'll have a sound maintenance plan to refer to year-round. That's a goal worth working for. Copies of the Unsurfaced Roads Field Manual are available from the U.S. Army Cold Regions Research and Engineering Laboratory at this address. Our first roads were the cart paths worn along the route of least resistance through our towns. Often, a trip of 25 miles was a day-long journey. If travel was a challenge, so was the task of maintaining and improving these public ways. Since the turn of the century, however, the tools designed for this work have grown steadily more powerful, more time, and cost-efficient. But even with our current knowledge of paving theory, and with sophisticated equipment to carry it out, there remain many challenges to efficient road maintenance. The people responsible for this task are caught in a bind. Town officials and road superintendents are mandated to keep roads in good condition, but their budgets are tight and getting tighter. They find themselves reacting to the worst road problems as they occur and as the budget allows. With this predicament in mind, another road maintenance tool enters the picture: the Pavement Management System. In the simplest of terms, this system helps you to gather and organize information about your roads, and then to analyze that information. These systems can tell you which roads need help first, which ones are getting better, and which are getting worse. You will make better decisions about how, why, and where to spend your money. And the perspective gained helps you to improve your whole road system with available resources. One system, which is being used successfully by over 150 cities and road agencies, is called PAVER. It was developed by the U.S. Army Corps of Engineers after several years of careful study. PAVER starts with a complete inventory of your roads, both the extent and condition. This information is then entered into your computer, and PAVER's analysis helps you with ranking, budgeting, and forecasting. It doesn't require outside consultants, and it doesn't require a large database. There's also a system called MicroPaver for use with microcomputers. It allows road supervisors to use PAVER right in their offices with very little training. Calculations can even be done manually if no computer is available. Since over 75% of the roads in this country are unsurfaced, the Corps of Engineers has also developed a system for the management of these roads. Used in conjunction with PAVER, the Unsurfaced Roads Management System gives you the information you need to track the condition of your unpaved roads. PAVER has proven to be a true money saver. The city of Tampa, Florida began using the system in 1982. Today, officials estimate that PAVER saves the city approximately $1 million each year. So PAVER can be counted on to help you get the most for your money. But there are indirect benefits too. A proper road inventory is indispensable. You can manage much better when you have at your fingertips a full and accurate account of your roads. An inventory will also help you to secure state and federal funds. Your road conditions will be documented in objective terms, not an observer's subjective judgments. These objective measurements and records mean that if your road superintendent leaves or is unavailable, your road maintenance program can continue uninterrupted. Your road maintenance plan may be explained and justified to anyone with hard numbers. And you'll be able to develop forecasts of future road conditions based on known deterioration rates and the maintenance alternatives. In the unfortunate event that town officials are sued because of an accident caused by a road maintenance problem, the courts are less likely to award damages if the town was following a documented road maintenance plan. The investment required to initiate a pavement management system is small relative to your whole road budget, and annual costs after the initial survey include only updating those inventories. Pavement management systems are receiving wide support nationally. The Federal Highway Administration has directed each state Department of Transportation to develop or adopt a statewide pavement management system. The idea is spreading. Many regional planning commissions and counties have already adopted plans. So, when you find yourself in the time and money crunch of too much road to fix and not enough money to do it with, take a serious look at road management. More information is available from CREL. We will send you the latest information on getting started with PAVER, and will include a copy of the Unsurfaced Roads Field Manual. There are also videotapes to help road superintendents and their crews get started with the Unsurfaced Roads Management System.